Welcome to the Quadratics Masterclass, Part 1. In the next few minutes, we're going to be going through the key skills you need to know in your exams, all to do with quadratics. This is solving, the turning point, and sketching. In this part, we're going to be going through solving, which in itself is quite a hefty topic. So by the end of these videos, you're going to be able to walk through exams confidently. Any sort of quadratic question comes up, you will be there ready to solve it, okay? So let's get on with it. Solving is the first one. So first things first, what is a quadratic? A quadratic, so you might see a line, y equals mx plus c. So if you've seen that, that's a line, okay? All it is y equals something x plus something. So these are our numbers here, m and c, known as coefficients. The quadratic is exactly the same. It's y equals ax squared plus bx plus c. And if you notice, this and this is the same thing. The only difference in a quadratic is it has this little bit here, the x squared term. So if you see a thing that's a cubic, it actually looks like this. Again, similarities. The exact same thing. It's just got a number here, number here, number here, and it has a cubed term. That's good to know. So a quadratic looks like this. How is it a quadratic? If you have the highest power of x is a 2, it's a second order equation, meaning it's a quadratic. That's what we call it. Good. So what does a quadratic look like? Well, if a, that you see here, is a positive number, it's a positive smiley face. And if it's a negative number, then it's a, you got it, frowny face there. So that's what it will look like on a graph. And this can look like anything. Can look squished, can look flipped, can be up here, it can be stretched. Quadratics can look like all sorts. And what determines that? Well, A, B, and C, what those equal, determine what the quadratic looks like. Amazing. So let's go through. When we talk about solving a quadratic, let's have an example quadratic here. So imagine if we had x squared plus 4x plus 4. First things first. What's A? What's B? What's C? A is 1 here because there's one x squared term. Some people think that that's a 0 or it's an x squared. No, A has to be a number, okay? B is 4, positive 4. If there's a negative with it here, it'd be negative 4. And C is 4. Good. So, therefore, the way we solve this, so y equals this function, here's our quadratic. Now, we want to solve this for x squared plus 4x plus 4. So, imagine you saw this in your exam, and it says factorize this or solve this, okay? So, to solve this quadratic, we need to understand something. I've just said that there's ax squared plus bx plus c, right? This is the expanded form, or its normal form, okay? There's the factorized form of a quadratic, which might look like this within two factors. So set of brackets. All you need to know right now is that you can get from one to the other and they have their purposes, which we're going to go through now. All we need to focus on right now is how to get from this to this. And then we're going to go through how to get from this to, you guessed it, this. And then we will show you how that's useful in the up and coming videos. Good. All right, let's go through this question then. So we need to factorize this and we're trying to solve it. This is the process. So we have our numbers here and we have to find two numbers that times to get 4, this last number, and add to get 4, this middle number. This is how you always do it. Times to get the last number, add to get the middle number, which you probably guessed it is 2 and 2 and 2. Then what we do, we have two sets of brackets. We put x at the start. We do plus 2 and plus 2. Why? Well, because you've got 2 here, which is this one, and 2 here, which is this one. Therefore, this equals 0, remember? Now, all we do is we say, okay, well, A, B. Imagine this is A and imagine this is B. This is just me proving a point here. So, okay, in order for A times B, this thingy times this thingy to equal 0, two things have to be true, or three things. They both equal 0. One of them equals 0, or the other one equals 0. In other words, all you need to do to solve this, when we say solve for x when y equals 0, and y equals 0, is you literally cover up 1. And you say, okay, if x plus 2 equals 0, then x equals minus 2. Done. That's it. That is one solution or one root. Let's do the other one. So we cover up the other one and we notice, oh, x plus 2 equals 0. So therefore x equals minus 2 also. So you have two roots. In this case, they are the same root. They're not always the same root. So what does that mean for a quadratic? Well, that means on a graph, it's going to touch on the minus 2 point here. And how do I know it's a smiley face? Well, let me look back at the expanded format. Well, I know that this is a 1 for a. And if a is positive, you guessed it, it's a smiley face. Good. Now, what if I wanted to find where it crosses through the y-axis? So what if I wanted to know that there, where it crossed through the y-axis? How would I get that? I know it's going to cross the x-axis or hit the x-axis at minus 2, but what about the y? So how do we solve for that? Well, what's the x point at that y point? Well, x is 0 when you got the y point of like c, for example. So, well, if our original equation is y equals x squared plus 4x plus 4, we'll just substitute in x equals 0. Then that goes away and that goes away. And then therefore y equals 4. In other words, this number at the end is always your y-intercept, which is 4 here. Good. We're on our way to solving quadratics now and drawing them out on a graph. Amazing. So now we know how to factorize. Let's have a look at how we go from factorized form to expanded form. I've got 3 questions here that I wanted to run through and just show you how to exactly go from factorized to expanded. So let's look at this one here real quick. So this one, the way we factorize is we do this times this, this times this, this times this, and this times this, okay? Let's do it step by step. X times x is x squared. X times 4 will be plus 4x. 3 times x is going to be plus 3x. And then 3 times 4 is going to be plus 12. These ones will always come together. You can, as in, come together as in you can put them together. So it'd be 4x plus 3x, which is going to be 7 lots of x. 12 there, x squared there. And if you look, if you wanted to factorize this, 2 numbers at times together to get 12 and add to get 7, of course, is 3 and 4, which leads you back to here, you see. So yeah, the really, really handy trick. Let's try this one here. The only difference is you have a number coefficient in front here. So let's times that out. And here, sorry, you're going to have 2x times by 3x, which is going to be 2 times 3, which is 6 times x. So x times x is x squared. Good. 2x times minus 4, which is going to be minus 8x. 2 times 3x, which is going to be plus, because it's all plus, 6x. And then it's going to be minus 8. These two can come together, remember. So it's going to be 6x squared minus 2x minus 8, because you've got 8 minus 8 and 6. Amazing. So that's quadratic. That's probably the hardest quadratic you'll ever want to expand. And then this is another more simple traditional one you'll see. What about this? So let's give this a go. So this is actually 1, 2, 3 things. So somewhere in here, you're going to have an x times an x times an x. So you're going to get an x cubed term. So this will be a cubic. Another reason why is because this will have 1, 2, 3 roots, which actually, if this equals 0, our roots would be x equals minus 2, x equals minus 3, and x equals positive 2. So you would have 3 roots as a cubic looks like this. So it would go through, minus 3, minus 2, and 2, similarly to that. We don't need to worry about cubics too much, but they may give you this question, give you 3 or 4 marks and say, can you expand it? So if you could do that, that's a really good trick to learn. So here it is. All we do is we basically expand 2 of them and we just ignore the other one. So I'm going to expand these 2. So let me highlight here. These 2 are going to be expanded. I'm going to ignore this one here. So let's go. So it's going to be x times x, so it's going to be x squared, x times minus 2, so it's going to be minus 2x, 3 times x is going to be plus 3x, and then 3 times minus 2, which is going to be minus 6. Combine those middle ones together, and we're going to get x, just x, 6, and x squared, plus x, and plus 3 and a minus 2 gives you a plus x. Good, put them in brackets, put this here next to it, and all we do now is we times this out by 3 and this out by 3 there. So that would look like this. So x times x, let me just clear this up a little bit. It's going to give you x times x squared, which is going to be x cubed, x times x, which is going to be x squared, x times minus 6, which is going to be minus 6x there. And then for the next one, we do 2 times minus x squared, 2 times x squared, which is going to be 2x squared, 2 times x, which is going to be plus 2x, and then 2 times minus 6, which is going to be minus 12. You see how I've layered them, as these now can be put together. Adding that all together is going to give you your cubic, which is x cubed plus 3x squared, and that's going to be minus 4x minus 12. And that is your cubic there. In GCSE, you won't need to factorize this, but you might need to expand to get to it. This is a cubic. So for quadratics, there are 3 methods to solving them. We have just done the simple method here. There is another method called the AC method. I'm going to go through it now. So simple means when a equals 1. When a equals 1. For example, x squared plus 2x plus 3. And it's a solvable, a nice thing you can do. A nice one, it gives you nice numbers at the end. That's the simple method. The AC method is used when a doesn't equal 1, and we're assuming it solves into nice numbers. And the other one is the, I'm going to call it F, the quadratic formula, okay, which you might have seen before. So these are the 3 methods in solving quadratics that you will need to know. And I'm going to be going through these in these videos on your screen right now. So feel free to watch these now to go through these next methods, and you'll be able to solve any quadratic that ever comes up on your paper.